Hello everyone. In this lecture, we'll understand and derive the analogous elements of force voltage analogy, that is also called as loop analysis, or this force voltage analogy. It is based on the loop analysis. Now in this method, the force which is in the mechanical system, it is analogous to the voltage in the electrical system. Now here we'll derive the other analogous terms for this force voltage analogy. So we'll consider this electrical system here. So, or the electrical network, sorry, this is the electrical network where you have resistance, inductance, capacitance, and you have the voltage V of t and current I of t. Now we will apply Kirchhoff's voltage law here. Okay, that is a KVL. We'll apply the KVL and we'll write the equation accordingly. So what happens? V of t is equal to R into I of t. That is the voltage across the resistance. Okay, that is I of t into R, or R into I of t, plus voltage across the inductance. It is given by L into di of t by dt, plus voltage across the capacitance or the capacitor. It is given as 1 over C integration I of t dt. Now you take the Laplace of this equation. V of t becomes V of s, that is equal to I of t becomes I of s, R as it is, plus L as it is, di of t by dt. Its Laplace will be s into I of s, s into I of s, plus 1 by c, 1 by c, that is 1 over c as it is, integration of I of t dt. Its Laplace is I of s by s. Okay, integration I of t dt, its Laplace is I of s by s. Therefore, this complete term can be written as I of s divided by sc. Now, in the previous video, we have seen the method or the procedure to obtain the equilibrium equation for the mechanical system, where we got the equilibrium equation as f of s is equal to m into s square x of s plus bs x of s plus k into x of s. We'll take this as equation 1. Now, if we compare these two equations, here these two equations cannot be compared. Why? Because these are not in the same form. Here on the LHS side, V of s is analogous to f of s. But if you observe this equation, you don't have any s square term here. Whereas in this equation, you have s square term. And also here 1 over s term is not there in this equation. You have 1 over s term. We have to bring these two equations in the same form. We will adjust this equation such that we get the s square s terms here. Okay, and we'll remove this 1 over s term. We want to bring this equation in terms of this equation, not in terms that is same as that of this equation. If you want to compare these two, both must be in the same form. So what we'll do is, here wherever I of t is there, we'll replace it by dq by dt, where q is the rate of flow of charge. Okay, that is current. Current is the rate of flow of charge. This q is the charge and current is the rate of flow of charge, that is dq by dt. Now we'll take the Laplace of this. I of t becomes I of s, and dq by dt, it becomes s into q of s. So here wherever I of s is there, we will replace it by s into q of s in this equation. Okay, this equation. So V of s as it is, then I of s, we will replace this by what? S into q of s. Okay, so s into q of s means what it will become here? It will be s square q of s here. Okay, L into s, I of s. L as it is, s as it is, I of s will be s into q of s. Therefore, s into s will be s square q of s. Next we'll write for this equation, this term, that is I of s into r. So here r as it is, I of s will be s into q of s. Then next plus I of s will be replaced by s into q of s, where s in the numerator and s in the denominator gets cancelled, you get q of s by c. So it is 1 over c into q of s. Take this as equation number 2. Now this equation number 1 and equation number 2 both are in the same form. That is, you have here s square term, then you have s term, and this term where you don't have any s term in the third term. Okay. Now we will compare these two equations. F of s, it is analogous to v of s. Then next you see the coefficient of s square, that is m. So here mass, it is analogous to inductance. Okay. Then you have b. B is analogous to resistance. B is what? It is friction constant. So it is analogous to resistance. And K, that is the spring constant, it is analogous to the reciprocal of the capacitance, that is 1 by C. And this X of S, it is the displacement. Displacement is analogous to the charge Q of S. So here these are the analogous elements which we derive from this force voltage analogy based on the loop analysis. So what we have obtained, force is analogous to voltage. Then you have mass, which is analogous to inductance, that is L is analogous to mass, inductance is analogous to mass. Then you have R, resistance is analogous to what? Resistance is analogous to the friction constant B. Then you have 1 over C, which is analogous to K, that is the spring constant. Okay, this is how you derive the force voltage analogy. Now this is the these are the elements, that is the analogous elements of the force voltage analogy. These are for the translation motion, these are the rotational motion, and this is the force voltage analogy, that is the electrical analogous elements for force voltage analogy. So force and torque, these gets replaced by voltage in the force voltage electrical analogous network. Then you have mass and inertia. These are analogous to inductance. Friction in both translation and rotational, you have same, that is the friction constant. It is analogous to resistance. Then spring, it is analogous to reciprocal of the capacitor. Displacement x and angular displacement theta, these are analogous to the charge q. And the velocity, that is x dot, you can write velocity as x dot also, that is equal to dx by dt. Whereas in rotational motion it is theta dot. Here this one, theta raised to dot, this is nothing but d theta by dt, that is nothing but the omega, that is the angular velocity. Okay, so that is analogous to what? It is analogous to current I, that is equal to dq by dt, that is the rate of change of flow of the charge. Okay, so these are the analogous elements of the translation, rotational, and the electrical system based on the force voltage analogy. These you need to remember because these will be used in the problems.